Hello, hello, beautiful YouTube. I am here with Mike from Faraday Research. I believe this is our fourth or maybe fifth interview now. We just
Yeah,
finished up on Leak Project. And,
I like
well,
that new intro, by the way.
thank you. Campbell made that, so
Oh, did he?
hopefully he gets the invites and checks his email or gets the notification that we're live on his channel and joins us, checks his email and joins us with the in here. But
Yeah.
I will let you give yourself a little introduction here and
So,
uh,
what kind of direction do we want to go? Right
with
into my project, or do we want to touch on something else?
you're talking about how what gave you the idea for the Faraday name, and then from there into your next idea and project.
Yeah, good question. Uh, f- Basically, it all boils down to all the experiments that I've done over the last 5 years, whether it's the N machine or the pulse motor generator or the Don Smith generator or just all the experiments that I've done and accumulated over the last 5 years. It all falls back on Michael Faraday, Faraday's law of induction. Oh, and the fact that he was the one who created the very first generator says it all right there. Because the energy that we use today that run our lights, run our motors, everything runs on the Hertzian frequency, the waveform. Either
Yeah,
it's alternating or it's direct current. And electromagnetic induction, it all goes back to Faraday. It all goes back to Faraday, and that's why I felt that I should call it Faraday Research, because that's where it all began. Really, that's really what changed. It got to the point where, okay, we know how to make a battery, we know how to store electrical power, and now Michael Faraday figured out how to make it uh, electromotive force and also generation. And
gotcha.
realizing that the second you put power through a wire, electromagnetic field is created. And in order to make electricity, you need uh, electromagnetism, and you need electromagnetic dielectric. With those two components, you have the electricity. So as long as you have those components together, you have electricity. So, and that was all part of Faraday's, research in the beginning. Perfect example would be the Faraday disc. Spinning the copper disc, and then you got two magnets on either side, and that generated amperage. That was the very first electrical generator. And then after that, it got into creating the electromagnet, being able to create electromagnetic field. He was able to isolate it. He was able to get compasses, and every time he put power into the electromagnet, the compasses reacted to it. So he knew there was a force, lines of force involved. And that's where it all started, is Faraday. So that's why I call myself Faraday Research. Because
And,
everything we do is
and it's
all goes back.
nowadays Faraday. All you hear is Faraday cage. So it's like your Faraday research is letting the knowledge out of the cage. You know.
That's right. I'm not going to have all the answers to everything, but if something I put on my channel sparks an idea in somebody's mind and say, "Hey, that that is an idea," and that leads them to a breakthrough, then it's this manifestation of ideas and information and throwing ideas on the table. Um, you know, will spark somebody's innovation and to do something and create it. And if I could, give them a little piece of information that's going to say, yeah, you know what I mean?
Exactly. Sharing
That's
the
that's
aha moments.
that's exactly it. So, um, yeah, that's part of the reason why I do the YouTube channel, because ultimately, in the end, the ideas that every YouTuber that's doing this stuff will spark the idea for the person to implement into his system, and actually at one day is gonna nail it and say, I've created this generator. It produces free energy, takes a little or very little energy to actually run it. And yeah, it's something. And then you basically just share it with the world, because going to get a patent is a waste of time, because all you're doing is submitting your idea to the government. And then if it goes against their interests,
If it
they're gonna,
works, they'll
yeah,
say
they'll seize
sorry.
it. They'll seize it.
Exactly. You're just condemning yourself.
That's right. So the way we're going to win this game is, don't even think about patents. You're wasting your time. You're
It's
wasting your time and your money,
right. And
right?
it's build it, share it, and get as many other people to build copies and share it. And it's essentially the exact same thing as what cryptocurrency is in the open source code. That
Yeah,
if you don't really know the underlying aspects of what cryptocurrency is, it's open um, like software code that anybody can then read and then add to and help develop and then evolve it. And it's the
yeah,
sharing of knowledge, the open information. And the funniest thing is, like, when you hear on the news, like, oh, the hackers, they shut this down, or they did that and they were paid in Bitcoin. It's like, no, that's an inside job. If you, like, anyone that's a hacker that understands code understands that blockchain is a series of ledgers of every transaction, so it's completely open and transparent, and
that's
there's
right.
no way of hiding, like
Right.
it. But yeah, so it's
That's the
open
way we
source.
have to treat this technology. We have to be, you know, keep it open source, share the ideas. You know, it doesn't matter if, say, 10,000 people are working on a system and in the end it fails. It's not a failure. This is what people got to realize. A failure is going to mutate eventually into something that actually works. So, failures, don't be discouraged by failures. I've had devices that don't work, and that's fine, but you learn from it, and you have to learn from your mistakes. As an experimenter, that is basically, you have to do that, and don't expect to nail it the first time. It doesn't work like that. It might take 10 versions of the same project to get it right. You know what I mean?
Exactly,
You
trial
just
and
keep,
error.
yeah, it's a trial and error, you know and that's the way Edison was in a lot of aspects. He was a trial and error guy, where Tesla, and I kind of have the same um, ways of designing stuff like Tesla was able, like in Iron Man, where um, Tony Stark is building his new Iron Man suit, and he's got that holographic image in front of him, and he's spinning it around with his hand and rearranging stuff. I can do that with my mind. I can do it the same way in my mind. I can envision the motor in front of me. I could take parts out. I could switch it out. I can do anything. It's a very, not too many people can do it. I can. And usually when I build, like when I built my pulse motor, I built it from the ground up, and it worked the first time.
You built it in your mind
I,
first, and then you
that's right.
manifested that
And
design.
I actually even tested it in my mind where stuff might fail. And not too many people can do that. It's not, it's one of those qualities. Either you can do it or you can't. I've been also studying the mind for a long time. Actually, I've been training my mind for ESP experiments and stuff like that. And I've done some pretty crazy shit, let me tell you, with ESP stuff. So really, it's not just like you have to live it, really.
Yeah, exactly. It's
You have to live it.
experience. You have to experience something to truly understand it. And once
It
you
has to
have
be,
lived that experience, you have that new set of glasses. You'll never see anything the same way again.
yeah, the way I look at the world 5 years ago is completely different than what it is now because I live what I'm doing. Like, my job every day is, I'm an aerospace machinist, so I'm working with machinery all day. I'm working with very expensive robotic systems. And, I even as a kid, I was designing robots, I was building with Lego. So my skills started at about the age of 3, okay? And just, kept going step by step as I got older and I got better and better. And now I can build some pretty cool shit, right? So
Absolutely. And so we were just on Leak Project there, and you're telling Rex and Jeremy, alien scientist, about a couple weeks ago with your spark gap, you were playing around and created like a little mini EMP explosion or pulse at your house.
yeah, I almost fried my power supply. uh, yeah, when you're playing with the Don Smith generator, and if you slow down the frequency and you separate the spark gap, say like to like a half an inch apart, you're going to get a very large arc. And if you have it hooked up to a coil, you're going to create what's called an EMP. And that EMP basically fries electronics. So I killed one multimeter already, fried the shit out of it, and I almost took out my friggin' power supply. The LED screen, half of it works, half of it doesn't. So, like, yeah, oh, it's very easy to destroy. See, when you're playing with the Don Smith or the Tesla frequencies and potentials, a lot of the measuring equipment that you have is not going to work.
It's on a different wavelength, right?
That's
That
right. It's designed for hertzient levels, 600 volts, amperage, yada yada. But when you get into the Tesla frequencies, a lot of these meters are going to get fried. And like by accident, I did that EMP, and shit's going to happen, right? So yeah,
100.
I know a lot of guys out there. When they're playing with the Tesla stuff, they keep their electronics very far away.
Yeah, I was just about to say, I hope you didn't have your phone on you.
Oh,
Clearly
I
you
did.
didn't, right?
Oh shit! The one time I had it, I had an EMP, and I saw the lights on my power supply starting to blink. I literally grabbed my cell phone off the table and I threw it onto the couch.
Nice save.
So
That's a good
yeah,
save.
I'm like, oh shit. So yeah, that's the thing. When you hit the wrong frequency, you're going to do some damage.
You're jumping into a pool or an ocean of energy, right? It's like getting yourself wet with the frequency.
Yeah,
You
exactly.
don't have your pants on you when you jump into the swimming pool.
Yeah, you're going to have a big shock when you land in the water.
And
uh,
people, this is a reason why you do not try these experiments at home. Like when I dick around with electricity, I'm only using like a D battery, and Mike is a actual electrical engineer, and been working with it his whole life, and still has almost had accidents. And
yep.
like, if you don't know what you're doing, you're gonna end up in the ground.
Yeah, I got shocked a few weeks ago and it felt like hitting like, from a defibrillator. Oh yeah, that shock, almost knocked me right off the chair. So I was very, very lucky. That could have ended very badly for me. Actually, I should have actually went to the hospital and get my heart checked out because I'm a little bit older now, but getting hit by 15 kVA from a non-discharged capacitor, it hurts. you know, because when
Yeah,
it hurts, trust me. It hit me like, Mike Tyson just gave me a shot right to my sternum. And yeah, it can do damage to you. So when you're playing with these potentials, and I actually did a video on how you short out your capacitors when you're using them for that, you know, that same reason, if they discharge on you, those capacitors will pack a huge punch. And so, yeah, even though that I'm experienced and I work with this stuff all the time, yeah, from time to time, I'm going to have a mishap where, I'm going to get a good lifter, right? And it just, I said to some people, that correspond with me in the comments on my videos, I said, if you don't feel comfortable with this stuff, don't get involved. Really, honestly, you know, there's many other devices that you could work on. And
exactly. Stay within
so
the comfort level always, and the knowledge level especially. Like don't just stick the old fork into the electrical outlet and think you're invincible.
yeah, not a good idea. I did that when I was 7. So that's not a good idea.
You
You
just
you
been
let you
electrified your whole life, Mike.
yeah, it's yeah, it's an experience. And you learn to respect electricity after that in a big way.
Definitely. I know with my own like monoatomics, it's like you, the average person as well. Like if you can't handle this stuff, it absorbs straight into you. And if you have like the oxides of the metal, like not in the pure monoatomic plasma, but in the plasmoids, you're gonna get heavy metal poisoning very quickly. And also, if
Yeah.
you're using other metals other than like zinc, copper, silver, and gold, like aluminum or mercury or something like that, that's going to go straight into you and give you
Well, yeah,
extreme heavy
because
poisoning.
yeah, exactly. Because the human body we're alkaline to a point, right? So therefore, electricity is looking for a ground, and we just happen to be a pretty damn good ground. So that's always something you have to, realize that electricity is going to find the ground, and if you make yourself the ground, well, that's exactly what's going to happen. You're going to become the ground, and
Right?
it's undiscriminatory. It's going to choose you because our bodies are like 73% water, right?
And
So and
salts
water,
too.
well, the alkaline, right, which makes us basically a walking battery, right?
It really does.
But yeah, what's other stuff we're going to get into? I guess I'm going to get into my new project that I'm working on. It's kind of like 5 years worth of work kind of thrown into one.
So you're
And
connecting essentially your end machine, your pulse motor, and your Don Smith generator into one idea.
yeah, exactly. Sorry, I had to put on microphone. I didn't want to cough over there. Yeah, essentially that's basically what I'm working on is amalgamating all these different ideas into one system. Now, when I had this vision on Tuesday, we were talking about this actually before we went live. That I always, when I take my water, my special fractal water, it puts my brain into hyperdrive, so I go into my little zone there at work and I'm drinking my water and my mind starts racing like 100 miles an hour. And I had this vision of like a flywheel. All bodies in motion tend to stay in motion. Okay, so let's think about the universe for a second. Well, we have planets spinning. Okay, they're in a vacuum. So that means there's no resistance in the vacuum. So the body in motion is going to stay in motion. And that's part of the reason why our universe works the way it works is because it's floating in a vacuum. And when you got a planet the size of ours and it's been spinning for 4.5 billion years. Well, that's over unity right there. It's an endless
Right?
power. So the Earth, in essence, is a giant end machine,
It
right?
is.
And the space shuttle, I believe it was in 2011, they had an experiment where they went up with the shuttle, and it was called the tether experiment. And they let this very long metallic wire out the back of the shuttle. Well, they didn't realize that they were going to get the shock of their life, and the thing broke free from the shuttle and started drifting away. So they, I guess, crossed the equator, and that would be the point of where the amperage and the power of the generation of the Earth hit that conductor on the back of the shuttle and blew it to smithereens. So that kind of proved that the Earth is a giant end machine. They never disclosed that information to the public, by the way. They said, oh, it just mysteriously just ripped off the back of the shuttle. Well, no, if you think about it, it got blown to shit. That's what happened. A
Giant
huge,
charge. It
a
shows that it's an
massive,
electric universe
yeah,
as
it's a
well.
massive charge hit it. And it crossed the equator, and that was the end of it. It vaporized it, separated it from the shuttle. Like, could you imagine the amount of potential that went through that wire?
And it's like
It's
this exact
mind
same
boggling.
grounding wire that all this Antiquitech has, essentially. Of you have your radio pole going up, your antenna going up, and then your grounding wire going into the earth. And
Right.
it creates a giant differential, and that is a source of free power, but huge power as well. And like if you know what you're doing, you can create lightning. Like that's the amount of power. It's everywhere, it's free. And well,
Yeah, and then it goes
clearly NASA doesn't understand it.
well, it goes to Tesla. He was the guy who created lightning. He harnessed the power of the earth to create lightning. Put the forces of nature into a mechanical device, and he was able to create lightning. So as soon as you learn the fundamentals of what exists in the universe and how things work, that you can actually reproduce that into a machine that can create the forces of nature artificially. And that was what made Tesla so special. He was able to figure out how to bring the forces of nature into a device, right?
And then some.
Yeah. So anyways, yeah. So going back to my device, so I figured, okay, well, bodies in motion tend to stay in motion. Okay, well, we live in, we don't live in a vacuum. We live, with atmosphere around us. So there will be entropy of the system. But if you create a flywheel device, okay, that's say, okay, I'll just shoot a number out there. Say it's 5 pounds. All right, you're able to speed that up to about 3,000 RPM. That that wheel is going to spin for quite some time. So they call that a mechanical battery. In actual fact, really, it isn't a battery because you're using inertia as your power source. So as my brain started racing, I go, okay, well, let's hook that flywheel up to a small little generator that's going to create enough voltage to get my Don Smith generator working. And now we got big power. So now we take a little bit of that big power from the Don Smith generator and hook it up just like you would make a pulse motor. So you would have a coil on the leading edge of the motor, put 4 to 6 magnets around the wheel, and have your reed switch hooked up on the side. And as it's generating power from the inertia, that power generates power with the generator underneath the flywheel. Send that power to the Don Smith generator, which jacks it up into the thousands of volts. And now you can distribute it to a load or to sustain the run. And there you go. You got a fully looped system, and you could set it up like on a timer circuit. So let's say it's going to spin for 5 minutes. Okay, well, say like uh, at 4 minutes of the free running of the flywheel, you engage the pulse motor, and now the pulse motor is going to have enough punch to get that flywheel back up to 3,000 RPM. When you achieve 3,000 RPMs, you shut the pulse motor part off, and you let the Don Smith generator run your loads. And there you go. You have a fully looped system, and it will sustain itself. And inertia is something that we don't really think about too much anymore. They were using it back in the 17 and 1800s. Um, we were talking about that bus earlier in the night that they were building in Switzerland. The gyro bus, they called it.
Yeah,
So
that's cool. I did not
the,
know about that at all.
yeah, that's very cool stuff. And
1920s, you were saying, and it
yeah,
was these buses that had giant stone spinning flywheels in them in
yep.
Switzerland, and they were powered just by these flywheels.
Yeah. There were 3,000 pounds from what I remember. Yeah, 3,000 pounds. They had a motor generator on top of it, so it would have two functions: one to speed up the flywheel, and then when that shuts off, it then turns into a generator, and that electric power powers the electric motor that moves the bus. So every 6 kilometers, they would have a station. 3 booms would come up the top of the bus and touch these high powered wires up on a pole and give the electric power to the motor to speed up the flywheel again. As soon as they get it up to about 3,000 RPM, it disengages, and then the bus takes off to the next one and does its whole bus route. So they were using that, but the technology was kind of primitive back then. They had some issues and wear and tear, and the flywheel was also near the compartment where the passengers sit. So
I'm just
there was
getting
some,
the image in my head of like Fred Flintstone with his feet going out like the Stone
yep,
Age, right? Like,
yeah, but it worked. That's it. It worked,
it,
and it's all by inertia. So if you can create a pulse motor generator that has, say, maybe a 20-pound flywheel, and you can get that sucker up to, say, 3,000 RPM, you got a huge amount of kinetic energy that is going to power your system for 5 minutes, 8 minutes. And in that time, you're generating power that you can put into a system that creates high voltage like the Don Smith generator, because all I need is 12 volts at 350 milliamps, and I can produce 9,000 volts.
that's just such crazy potential turnaround. Like
Right.
that's next level,
So,
and I can't
so
wait to get this working to
yeah,
show
because
people.
it's the way I seen it in my visions. The second I start it up, basically all I have to do is get it spinning to say 2,000 RPM. And the second I engage the pulse motor, I'll know right away if it's going to work. It should be accelerating and accelerating. It should actually, in actual fact, if I got it right, the thing will actually accelerate to the point where it'll actually blow up. Okay,
But
constant acceleration. The second you put that pulse motor on, that thing should take off. And if it doesn't constantly increase speed as you're running it, you won't get over unity. That's where you're going to know you're over the hill. You got it. Because if you cannot sustain 3,000 RPMs and it starts then dropping in RPM, that means you haven't done it. That what you have to do is when you turn that pulse motor on, it should be faster, 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 faster.
each time you
And
pulse it, you should be adding
it
energy instead of it. The
exactly
dipole is leaking energy somewhere in
right.
that
Right.
magnetic field.
If it doesn't do constant acceleration, you don't got it. If it keeps going and going and going, and keep going faster and faster, and you exceed 3,000 RPM and the sucker's going to blow up, well, you know you did it because it's constantly increasing potential. That's where you know you got it. So then what you would have to do is put it into cycles. So say you can get 5 minutes out of the flywheel. At 4 minutes, you would engage the pulse motor, say for about 40, maybe 50 seconds, and then put it on a timer relay where it will shut itself off. And now you're using the inertia that now you've got, and that just keeps the system running. You have to learn from nature. Nature is giving us all the clues. When you look at the example of our universe, all the heavy bodies out there have been spinning for billions of years. Nature is our teacher. We just have to realize it. It's great to have
Exactly.
ideas, but
Like
nature is
going back to like Schauberger and the great scientists of the turn of the century. They all got their ideas and their understanding from observing nature.
exactly, and nature is the answer. So it's a matter of being able to see what you know is true in nature and reproduce it into a device that you can use to make energy. And that's exactly when I was thinking about the flywheel, is nature is using a flywheel all the time, all over, everywhere. Even electricity. My vortex fractal water generator, it's creating energy by spinning in a centrifuge. That's energy being generated, and it does it in nature all the time. So
It's constantly in motion in nature.
it's nonstop. It's infinite. They say the Earth is slowing down, but you know what? If it takes 10 billion years for the planet to blow down, but I don't know about you, but I might have only 80 years in my body. You know what I mean? So to me, that's pretty well infinite energy, because, nobody can live 4 billion years, to see it slow down to the point where it would stop. So as far as I'm concerned, the Earth is a perpetual motion device.
I see it
So,
the exact same way.
they're using it on the International Space Station right now. They got I believe it's 2,000 pound gyroscopic generator. What it's doing is it actually keeps the space station at a certain angle in orbit. And when you gotta see, I don't know if any of your listeners out there have played with gyros, but when you spin a gyro to a high speed and you try to grab it and try to flip it, well, there are forces there that are pushing against that. That's why you can balance a gyro on its end and it doesn't fall. It's because it's creating the momentum to keep itself in a fixed position. So you can get into this with anti-gravity. I think gravity, there's a lot of credence to a gyroscopic type machine in anti-gravity.
100%.
Yeah.
The wave within a wave within a wave, or field within a field within a field, and
Well,
its
you're fixing
rotation.
it.
And rotation is a huge part of gravity that is not really incorporated in our current understanding of it.
It's gravity manipulation, right? So, I would love, if I were on the ISS right now, I'd be experimenting with gyros, because if you can see the true physics of a gyro in a zero G environment. So, obviously a spinning body is basically forcing out on its longitudinal. So this goes back to my one generator I made, the N machine, which originally was built by guys in San Francisco, and then Bruce De Palma kind of jumped on it and created the N machine. And I was saying, before we went on tonight, that I was hitting it with high voltage, and I was getting some anti-gravity effects of my N machine when I was hitting it with high voltage. So when you hit it with high voltage, it is now going in the same direction as the amperage would have been going. So now it's going out. So if you're spinning it on its axis, it's going out at the 180 and 90 degree, or sorry, at 0 and 180, right? It's going out the ends. So you're now creating a field. So that is also an electrostatic field. And in between the electrostatic field, you have a longitudinal wave. And I really believe the longitudinal waves that Tesla discovered is a big part of how we will basically crack the code of anti-gravity is the longitudinal waves, or you call it the monopolar energy. And I've even demonstrated that with my Don Smith generator, where I could take two Tesla coils and point them at each other, and I get my fluorescent light bulb. And when I get in a certain spot of putting the light in between the two Tesla coils, I start getting a black void. And that black void,
really?
yeah, I get a shadow in the middle of the bulb. And that
That's
is where the two monopolar waves are hitting each other dead on. They can't go past each other. So that black void there is counter space into a different universe or a different existence. And that's what, because that's the only thing that stop light is if it's going into another dimension.
Yeah, that's kind of like Ken Wheeler's experiments in the ferrocell, and he shows how magnetism is bending light, and he gets that same shadow, or
I don't think it's magnetism. I think he's working on the longitudinal frequency
okay,
because electromagnetism, as far as I understand, will not bend light. Okay. It's a frequency. Like we were talking about the harmonics of what do you call a transformer? Remember, we were talking about that. I honestly believe that some form of harmonics could actually bend light. And the only thing that I know that can bend light is gravity. So
huh.
if you got true gravity manipulation or change, you should be able to bend light, a non-ferrous material, right?
That's interesting.
Yeah,
Well,
like if you get a laser light and you're
yeah,
able
like
to bend it, that means you have manipulated gravity. That's an indication you've done it.
huh.
And
But
that's
then
all
like
done.
there's your what fiber optic cables and stuff like that. You're bending light through a crystal or something, a clear solid, right? That's something I've always thought, like pondered in
Well,
the mind, is how does that work?
well, I'll tell you right now, it's not from this world. I think
Right?
this all
Yeah.
is all part of the crash retrieval materials, and I think fiber optics were retrieved at Roswell if you're into that kind of thing. And I think that's what they developed fiber optics is, material that they found on these wreckage ships that have crashed, and even like the laser too. All some of this tech that we have today, I think is direct correlation with crash retrievals. I really believe that.
It would make sense. It's when everything started to develop and come out on like the real switchover from the old world technology to this, and then the analog as well to the straight digital.
Right. Like I think the real big technological advancement happened with the creation of the transistor, and when they were using quartz to actually use and manipulate the frequency.
Right.
That's when things really changed. Is when the transistor was developed by Bell Labs.
Not a lot of people really know or actually understand what the transistor is and how important it is, how it changes everything within the electromagnetic circuits.
yeah, it's being able to basically shut something off. It's a switch. It's a switching device. We don't even think about it anymore about transistors. It's old technology, but it's still used in almost every device you can imagine, right? And
Yeah,
then we
it's the building blocks. It's the one. It's what gives you the ones and zeros, the binary code within your
exactly.
system.
Excuse me. Yeah, and it led to eventually the microchip, the silicone microchip, right?
And though there's a Campbell works does a lot of work with another channel, UAP, and he actually a very fascinating video a couple weeks ago on microtransistors within the very first film, like the silver film elements or whatnot, and like basically showing that what we're using now to create the most technologically advanced nano transistors
Yeah,
actually existed in these silver image plates, picture images or film or something like that. It
right.
was just fascinating. I can't properly describe it. You'll have to see the video, but it's
Hmm.
just mind blowing.
I think we're at the point now where we could create machinery at the nano level is really kind of will accelerate computer technology and electronics. It's going to really change a lot of things. Stuff that 20 years ago we thought totally impossible to do, and now we can build circuitry at the nano level. That's you're getting into some real interesting science there, and it's going to accelerate stuff. Like look at the stuff that we're doing today. With supercomputers and AI and all that stuff starting to come online. Like artificial intelligence is going to happen. It's going to happen, and actually, Canada is one of the leaders in it. Believe it or not. So it's just evolution of technology, and I think because of the internet, um, it goes back to this old scenario. You call it the quickening. Art Bell had a really good book about that. He called it the quickening. What he wrote with Whibley Strieber, and basically he talks about this acceleration of knowledge. All you have to do is plant a seed, and then the flower is going to come out eventually. And that's exactly what's happened. We got seeded by some technology, and the great minds at that time figured it out, and that's when the technology really started to explode. And look, in 100 years, well, say 69 years, went from not flying to landing on the moon. So in 60 years, we made leaps and bounds in technology is mind-boggling. And then the stuff that they're hiding in secret projects is probably 150 years ahead of what we know exists.
Most definitely.
So, you know, it's just a matter of sharing information. Free energy is real. I know it's real. I've had interesting effects in several devices that demonstrate some really peculiar anti-gravity. I've had orbs showing up in the room. I've had black voids show up in my room. I've had time dilation, you know, and I'm learning all this stuff and I'm like, holy cow, because everything seems like it's all going connecting together in one way, shape, or form. And I guess probably one of the biggest discoveries that I've realized this year is why Tesla was using the spark gap. And there are a lot of stuff, a lot of science. There's another guy, Kenneth Shoulders. He was working with spark gap stuff, and John Hutchison, and how his metals were mutating and all that. And he realized the spark gap was creating these little, well, he calls them evos. um,
Okay, I think you're talking about The Martin Fleischmann Memorial Project. Bob, there is that the
Yeah,
one?
it
Yeah,
might be. Yeah, I'm not too
great
familiar with
guy.
that guy, but yeah, he's basically he Kenneth Shoulders believes these are actual entities from another dimension, and when you're using the spark gap, the Evo is actually able to enter the metal and actually explode the metal from the inside.
Now it's like some John Hutchinson
Yeah,
style of
well,
work right there.
that's exactly why Kenneth Shoulders was working with John Hutchison because he was getting these effects,
Oh, they were
and
working together.
yeah,
Okay.
they were together for a while. There's actually a couple of interviews on YouTube with them talking together. They were getting interviewed by somebody, and they were together talking about the Evos. And some of the spark apps I was working with, I was getting some interesting effects with um, what appears to be some forms of fusion going on in my spark gap
Yep.
because
I believe it.
material was actually forming on the electrodes of the spark gap.
Anytime you deal with plasma or you get like a plasma arc or any sort of plasma, it gives the chance and opportunity of a cold fusion reaction, and you will have some level of transmutation.
Well, you're opening up another dimension. I've almost
Exactly.
come to this conclusion that initiating a spark gap actually is opening into another counter space. Because that was the only way that Tesla was getting these huge voltages was okay, yeah, you're getting quite a bit of voltage from the coils, but he was getting excessive amounts of power coming from the spark gap. And the only way he figured that he was getting this was from counter space. And that led to the other experiments where he was working in Colorado Springs when he discovered the monopolar scalar, whatever you want to call it, energy that lies in between the static fields. So
Exactly. The ether energy is
the
what
ether,
it
yeah,
is.
exactly. So your the spark gap is basically opening up a orifice into counter space where the ether lies, right?
Exactly. And the more like um there's a second part to the interview that me and Campbell did with Rex yesterday that he just brings up phenomenal examples of showing how the ancient technology um, is straight ether tech, and it's a higher dimensional frequency energy technology and archaeology, and it was written out of our understanding. It was either lost at some point, or it was intentionally hidden and written out only a couple hundred years ago at the longest. And we're finally starting to get it back and understand it and share it with everybody and each other and prove it, and no longer believe the limitations that the controllers put upon us and live through experience
Well,
and know
that's
your
that
own truth.
exactly that you're exactly right because if Tesla had his way and he had his funding, he was just going way far ahead of everybody's understanding of electricity. Like
Exactly.
it blows my mind to think, and I've probably said this before on your show, that if Tesla was living right now in his prime, could you imagine the shit this guy would come up with?
Oh, I would love to be in
I
a lab with him, like building
my
one of
brain
those
would just like,
ion guns or something like that. Like,
my head would
wee,
just freaking
pew pew.
explode. Like the stuff that this guy would come up with, because Tesla had nothing back in those days. Multimeters weren't developed yet.
They were
You know,
building everything from with their own hands, like from
yeah,
scratch, right? Like,
from scratch. They didn't have transistors. They didn't have all the advanced super capacitors that we have now. They didn't have diodes. They didn't have any of this stuff. And he was so far ahead of everybody else that nobody knew what the fuck this guy was talking about. But he knew. And the only guy that could really confirm any of what Tesla was doing was Carl Steinmetz, when he was
Yep.
actually able to put everything that Tesla was doing. Steinmetz was the head of General Electric's research division, and he was also an experimenter as well, and it had over 200 patents under his name. He was actually able to reproduce what Tesla was doing, put it into mathematical science, and actually prove that he was doing exactly what he was doing. You know, and he also solved the problem of the AC motors blowing up. He, yeah, came up with the equations needed to develop the AC motor and what we have today, so it wouldn't blow up. So those two guys right there, they were real pioneers on creating what we see today.
Oh,
But
exactly. Like Tesla's patents are literally the base building blocks of every single energy and radio and wave technology that we have and use today in
yeah,
your every device that we
and
have.
it hasn't changed. The radio basically,
Yeah.
in essence, works exactly the same way as Tesla designed it to. It's just our technology now. We've got radios with all the bells and whistles now. We
I
got
would
techno.
almost say the radios worked better than by his design because he had the
Well,
crystal
yeah,
radio that talked to the other side, right?
right, with no power going in it, no power
Exactly.
whatsoever. He did one experiment where he had two antennas. They were 6 miles apart. On one side, he had a galvanometer, and on the other side, he had a tuning fork attached to the antenna. He rang the tuning fork, and when he rang it, it transmitted that energy to the antenna 6 miles away, and made the galvanometer needle move. So that proves you can propagate a signal through the air at great distance with little or very little power. That's why we can send a radio signal with basically a transmitter that we use in our cell phones today. We can, well,
Exponentially
that's
decreases the further you
well,
go, right?
the rover that's basically on Mars right now is using the same kind of transmission device that we have in our cell phones. And look how far away it is, you know?
Yep,
And when you
indeed.
think about it, that's all it is a cell phone transmitter, sends it up to the satellite that's in orbiting Mars right now, and then basically bumps the signal from the satellite to Earth. And you basically got, within 20 minutes, you've received the signal. Now, if people listen to Tesla and start building radios using his new monopolar scalar wave, we could have instantaneous propagation of signal from Earth to Mars. Like we are talking right now, we could actually have that same transmission in real time and video with Mars. That's how fast this waveform moves. It's faster than the speed of light. And that was his big discovery at Colorado Springs, is this monopolar um, uh, I guess you could say like electrostatic field scalar. Uh, it's proven that it can go faster than the speed of light. Well, if you
Right,
go,
exactly.
so that basically blows Albert Einstein's theory of relativity out of the water. It blows it up right there, because he's saying nothing can travel faster than the speed of light. Well, guess what? I beg to differ on that. And Tesla was not a fan of Einstein. He really ripped into his theories of relativity big time back in those days. And the problem is, at that time, the physicists were taking control. The dogma was there, and they were going chop, chop, chop to the electrical engineers of that time. And soon as Carl Steinmetz from GE passed away, That's when all electrical science died off. It was done. Because at that point in time, Tesla already basically pulled out of the scene because he couldn't get funding. Everybody blackballed him, and he basically became a homeless person for the last 40 years of his life.
Or so the story goes.
Well, he was, the guys that he did work for, they, let him shack up in hotels. But basically, he lived like a homeless man for the last 40 years of his life. He did do work on the side. He did some secret projects for Germany and a few other countries and stuff like that. But for the most part, Tesla was pretty much blackballed in the U.S. He was finished there.
Big time.
Yeah.
Because you had the Astors, you had J.P. Morgan.
Yep.
And like all of the elites that were
Jacob Astor, Jacob Astor, I think saw good qualities in Tesla. I think as the investor, he was the one who kind of supported him the most, and he was kind of against the elite rich at that time because they, this is kind of going in a different direction, but they were out to basically implement this, debt fiat system that we have today, where, the U.S. dollar is getting devalued, and basically, uh, backing your money with gold didn't exist anymore. It was going to go to the petrodollar. And Jacob Astor seen, their visions of what they want to do with the world economy, and he says, "No, I don't want to be part of that. That's going to fail." And so, anyways, he was the one banking family that were opposed to the cabal, and one thing led to another, and John Jacob Astor
was on the Titanic that sunk.
Exactly. And the second he died on the Titanic, the banking elite basically went out of control. And we're in our situation that we live in today. So.
Most definitely. Since Campbell hasn't showed up, though, I do have to take off here fairly quick to go get my girlfriend, but
Yep.
love
everybody. We did an hour. That's cool.
Exactly. So I highly recommend everybody, if you haven't checked out Leak Project, me and Campbell did a 2-part series on there with Rex, and then Mike did another one with us on there tonight. So this is more just an after stream. We started, Campbell was supposed to come because most of the people in the chat box are from Campbell's channel, and we're gonna cut her off here, and we will meet again in a few days. We're gonna be doing a special with Paul Cook again, and I can't wait to see what you come up with next week, Mike. And I'll send you a couple videos, or I'll text you here with some video links on.
Yeah, you got my number now, so text me whenever you want. Feel free to text me, and we'll keep in touch more often.
Most definitely. And love you all, and hope you have a good night and good day, and bless you all.
Okay, take care, everybody.
Bye.